Okay, so now looking at page 2, if we have let f of x equal the square root of x plus 3 and g of x equal the square root of x minus 2, find each of the following. So if we want to add these two functions together, we would have the square root of x plus 3 plus the square root of x minus 2. Okay, we can't combine those together. That is the simplified expression. But now we want to find the domain. So we know from this first one that x plus 3 has to be greater than or equal to 0. Okay, which tells us x has to be greater than or equal to -3. Then looking at our second one, x minus 2, we know that that also has to be greater than or equal to 0, which tells us x is greater than or equal to 2. With square roots, we want to see where do they overlap. So I'm actually going to do this on a number line, just so you guys can see it visually. So on our first one, okay, that's our x minus 3, or sorry, x plus 3. And then on our second one for x minus 2, we have x is greater than or equal to 2. So our domain is going to be where do they overlap, okay? Because if we plugged in like 0, that would work for this first square root, but it wouldn't work for the second. So our overlap from 2 to infinity is our domain. Okay. All right, so now let's look at composition of functions. So the composition of the function f with g is denoted f composition g and is denoted or defined by the equation f of g of x. So here's what I recommend. That little circle equals of, okay? And anytime we say of, we open our parentheses. Okay, so when we have f composition g of x, okay, f of means we open parentheses, g of x, and then close your parentheses. So we're going to take g of x and we're going to plug it in for f. All right, so looking at this first one, we have f of x equals 3x minus 4, g of x equals x squared minus 2x plus 6. So if we want to find f of g of x, so I'm going to always start this by rewriting it f of g of x. Okay, we're going to take our g of x and we're going to plug it in to this expression. So we have f of x squared minus 2x plus 6. And now we're going to take this expression and we're going to literally plug it in for the x value in f. So we have 3 times the quantity, x squared minus 2x plus 6 minus 4. Okay, and notice that x squared minus 2x plus 6, that's what we plugged in. So now we just want to simplify. So if we distribute, we get 3x squared minus 6x plus 18, and then minus 4. So our simplified expression for the composite, 3x squared minus 6x plus 14. Okay. So now let's go the other direction. Now let's find g of f of x. So start off by rewriting it. G of f of x. So now we want to figure out what is f of x, and that's the 3x minus 4. So I'm going to plug that in. So now we have g of 3x minus 4. So if we plug 3x minus 4 into all of our x's of g, we get 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So we need to FOIL. And if we FOIL, we get 9x squared minus 24x plus 16. Then distribute. So negative 6x plus 8 plus 6. Combine like terms, and we're left with 9x squared minus 30x plus 30. All right, now let's look at C. Now we want to find the composition G of F of 1. Okay, so there's two ways you can do this. We know that G of F of X equals 9x squared minus 30x plus 30. So what we can do is we could just plug in 1. And evaluate the function for 1. And that would give us 1 squared is 1 times 9. So 9 minus 30 plus 30 is just 9. Okay. But what if we wouldn't have done part B? Okay. What if we would have just been left with our first f of x and g of x and given this? So we're asked to find g of f of 1. Start off by finding f of 1. So f of 1 equals 3 times 1 minus 4, 3 minus 4, which is negative 1. So now we're going to take that negative 1 and we're going to replace it for the f of 1. So now we're just simplifying and finding g of negative 1. Okay, so if we do that, g of negative 1, we have negative 1 squared minus 2 times negative 1 plus 6. Negative 1 squared is 1. Negative 2 times negative 1 is a positive 2 plus 6. And that gives us 9, which is the same thing we got either way. Okay. So I don't care which method you use. If you've already done the work like we did in B, it makes more sense to do what we did on the left. But if you haven't done that work, it's easiest if we just evaluate each function. Okay. All right, so now what if we look at finding the domain of a composition? Okay, so actually I'm going to slide back up. So the domain of the composite function f of g is the set of all x such that x is in the domain of g and g of x is in the domain of f. Okay, so we're going to kind of break this apart. So let's start off with finding f of g of x. Okay, so if we do that, f of g of x, we're going to have f of g of x, which equals f of 3 over x, which equals 2 divided by 3 over x minus 1. Okay. We're going to go ahead and multiply everything by x, so that way we don't have a fraction within a fraction. So we have 2x divided by 3 minus x. Okay, so there's our composition. So if we want to find the domain, the first thing we want to look for is the domain of g of x. Okay, well, from g of x, we know x cannot equal 0. Okay, that's just something we know because x is in the denominator. Now we want to find, based off of that, what is our domain? So g of x is in the domain of f. Okay, so our domain of f of x, hold on one second. I X is in the domain of G, and G of X. Okay, so now we want to check that everything we plug in from G of X into F will work, okay? But if we do that, okay, if we plug in 1, it won't work. But the easier way we can do this is just look at this composition, okay? So if 3 minus X, okay, we know 3 minus X cannot equal 0, which tells us X cannot equal 3, okay? Well, if you plug 3 in for G of X, you get 3 over 3, which is 1. Well, if you plug 1 into F of X, 1 minus 1 is 0, which would cancel, and you'd be left with 0. Okay, so an easiest way, rather than using the definition, is if we just look at the composition. Okay, so our domain of F of G of X all together would be the set of all values of X such that X does not equal 0 or 3. Okay. All right, and last part, decomposing functions. So when we decompose a function, we're kind of looking for like an inside and an outside. Okay, so if we find F of X and G of X, and let's say that H of X equals the function F of G of X, okay? So based off of that information, we know that F of X is the outside and G of X is the inside. Okay. So our inside function, let's start there, would be X squared plus 1. Okay. If we take that away, and that disappears, we're just left with the cubed root. And well, we have to fit something in there, so we're just going to put X. Okay, so that's our two functions that compose together give us the cubed root of X squared plus 1.